Hello, everyone. Hope you can hear me loud and clear. Thank you so much again for joining our innovation stage. We have a great speaker coming right now, Charles Givre. He has been in our community for a long time. You may know him, and he's a new startup that we're all really excited about. So without any further ado, I would welcome Charles to the stage. You can go ahead and turn your camera on and get your audio going, and I'll be here if you need me.
All right, thank you, Daniel, and thank you very much for having me today. My name is Charles Givre. I'm CEO of and co-founder of DataDistillr, and it is our goal to make the world's data easy to query and use. And so, with that, I'm going to share my screen here and walk you through our intro and demo and show you all about DataDistillr. As if I can find the deck. So, and just a bit about me, my background before co-founding DataDistillr, I worked at Deutsche Bank and JP Morgan, and the problem that I saw there, and I was at NSA before that. Before I kept seeing that organizations were really struggling with what I would say is a very common problem in data science, and that's just simply getting data to a point where you can actually use it and make sense of it. And this, I work in the cybersecurity realm, so this is compounded by the diversity of both data types and formats that are existent in the cybersecurity world. Like, for instance, if anyone's doing any kind of serious cybersecurity analysis, you're going to be looking at log files, you're going to be looking at PCAP or JSON data. You might have data from Elasticsearch or Splunk or all these different data sources. And so, simply put, getting all this data so that you can actually use it and make sense of it is a monumental challenge. Now, some people have kind of had this idea that, well, you can put all your data in one place and then that will make this problem go away. But the reality is that just can't happen, because from at least from my experience, unless the company that you're working for was founded 2 weeks ago and everything actually is in one place, there will always be data all over the place. There will be Salesforce data, HR and their own proprietary systems, et cetera, et cetera. And so oftentimes when you're doing some sort of analysis, it's necessary to bring all this data together. So I've had this idea for a long time of building a tool around what I call a data abstraction layer. And what this does is the data abstraction layer acts as a black box between the user and the data. And so effectively, what happens is the user types in an SQL query into our query engine, then the query engine optimizes this query, sends it down to whatever source system their data lives in. The data is read and mapped to columns and rows, and then the user receives a clean table of this data. Now, we're building our tool around several open source technologies, one of which is Apache Drill. So if you're interested in kind of how this works, take a look at drill.apache.org, and you can kind of see how this query process works. But ultimately, the user experience is that you put in a SQL query and you get data back. And you don't have to know or care whether or not this data is coming from Splunk, whether it's coming from an API, whether it's a file system, whether it's whatever. It doesn't matter. You ask for data, you get data back. And then from there, once you have this, you can then use your whatever, you can put it into Tableau. You can then send this onward for if you're doing machine learning in like a Python or R. All of this becomes a lot easier because you've taken that piece of the puzzle that's arguably the most time consuming and made it a lot simpler. So now you might be wondering, well, what kind of data can you actually support? In terms of third-party systems, our query engine will support most relational databases, so anything with a JDBC driver, but we've tested it with MySQL, Oracle, the list that you see there. So basically your most commonly used databases. In terms of non-relational stores or NoSQL stores, our query engine will work with Elastic, Splunk, Cassandra, MongoDB, HBase, Kafka, Kudu, and there are more kind of in the pipeline. So it's pretty exciting. Now, in terms of file systems, we can support any kind of cloud storage. So if you have data that's in S3 or Azure or Google Cloud, you can just kind of point our tool at that. We support data lakes, Hadoop data lakes, and then we're working on connections to other storage systems like Dropbox, Google Drive, and kind of those kinds of remote storage. We support a whole variety of data formats, and these would include things, I mean, kind of your standard stuff like spreadsheets, but then we get into some more niche things like JSON data, XML, PCAP files, syslog, HDF5, PDF, bulk financial data, all kinds of stuff. We're looking at some genetic information, but bottom line is, if you have data, we want to be able to query it, and all of this maps nicely to to SQL queries. So yeah, and additionally, we can query APIs. If you have a data source that's coming from an API, we can query that directly. So you don't have to worry about how you authenticate, how you how you send post requests or get requests, all that stuff. Once we do some there's some minimal configuration, and then you can just query it as if it was a database table. So I want to walk you through a quick demonstration of this capability. And this is kind of a notional use case that we came up with. So the user is a data scientist, and the person's CEO comes downstairs and says, hey, I want to know how COVID is affecting our web traffic. So the problem here is we have to join our web logs with some COVID data that we found somewhere, and ideally produce something that's reasonably up to date. Now, for this purpose, we're simulating web data from Splunk, and then we have an API where we're going to pull the COVID data. So let's take a look. To query Splunk, it's as easy as this. So this is our notional logs. You can see here we have all of this data, and yeah, so there's really not a whole lot to really show you there. Now, the key fields, though, is the IP address, because that's going to tell us where the user is located, and the actual count of how many hits and what they did. So now, the COVID data, though, we want to get this from a live source. So there is this COVID tracking API. It says covidtracking.org, I believe. It's published by The Atlantic, and I think Hopkins as the kind of data source for that. But this query right here will pull back the data from this API in real time. So you can just query that with with the ease of SQL. Now, here's where things start to get a little sideways. So unfortunately, there's no common key between the Splunk data and the COVID API. So what we have to do is we have to create one. Now, the way we're going to do this is our tool has a number of functions that can enrich the IP addresses with geolocation information. So you see these at the top here. We have the get country, get city name, get postal code, etc. And that's how we are locating the user for the that was on the website. Now, however, there's a small problem there in that while we can get that information out of the web logs, the COVID data is indexed by state code and not by any postal code or city name or whatever. So we have to get a state name. And in order to do that, we have to bring in a third data source, which is a CSV file that has reference data for this. Now, if you look at about 4 lines from the bottom, you can see that we're joining these 3 data sets together simply with inner join statements. And so if you're familiar with SQL, this should look pretty comfortable for you. And the end result of this is we're able to take 3 data sources, join them together, not on original data, but on transformations of data that existed in them, and produce this summary, which could then be used for visualization or for machine learning or whatever you might want to do with it at that point. Now, our initial tool is just doing data exploration. However, we will include visualization and then links to downstream tools. We also do have a notebook interface, so you can pipe this data directly into a pandas data frame, and you can then model it using scikit-learn or TensorFlow or whatever machine learning libraries you might want to use. So in conclusion, I want to thank you very much for attending my very brief talk today. I really appreciate it. Our tool, DataDistillr, is going live at the end of the month. So if you would like early access, please go to datadistillr.com and sign up for early access. And if you have any questions, of course, please don't hesitate to reach out to me. I'm on LinkedIn, and my email is here. So thank you very much, and have a good day.
Wow, thank you so much, Charles. That was very, very interesting. To the audience members, I hope you enjoyed it. Again, feel free to reach out to Charles if you have any questions. A big virtual round of applause for Charles. Thank you very much, everyone.
Thank you.